Okay, so look at what they told us here. Thanks to Bondi for reading. Forgot we should maybe read. The graph of G is here. It says G is the derivative of F. So if I've got the graph of G written there, what can I say that's just equal to? That's just equal to F prime, Bondi. So if we're looking for when my function is increasing, we're going to say that's when my F prime is greater than 0. And when my function is concave up, that's when the second derivative is greater than 0. Right there, that's our point. Okay, you guys. Every graph we look at, I don't care if it's F prime or F double prime, you can always do this. And that kind of helps remind us of the values. If this is a graph of F prime, thank goodness for Bondi for reading, it's above the x-axis is when F prime is greater than 0. So if I were to highlight that, do you agree we're looking here, here, here? He says, don't look at this part. Don't look at that part. I agree. Lie. Okay. How would I get F double prime from a graph of F prime? Slope. What is F double prime here? Wait, it's what? It's greater than 0. It's positive, right? I don't want you to say increasing because it's actually constant, right? So it's positive. What's F double prime here? 0. What's F double prime here? Negative. What's F double prime here? Oops, I erased it. It's positive. So from where to where are both of these met? You're saying from 0 to 1? And 4 to, you know what? Check this out.
4 to 6.
Exactly. They did bound this graph. It's stopping at 6. Done. Then this is again talking about those points of inflection. Point of inflection is when your
F double prime is from changes sign.
love it. Oh my gosh. Point of inflection. F double prime changes signs. Look with this Greer. You just got this point. Give a reason for your answer. Boom. You already got it. Now we got to go find the x coordinate where that happens. Don't forget, you guys, this is a graph of F prime. How am I getting my F double prime? It's just the slope. What's my slope here? 0. What's my slope here? Positive here? Here. 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 Negative here. Where did it change signs? At 4. Everything else was 0 to positive, 0 to positive, 0 to negative. It needs to be it just needs to be at one point. We can't involve the long zeros. So it's at x is 4. Done. So as of yesterday, we were always using F prime to find maxes and mins. We're always using F prime, and that's fine. Because if this is a graph of F, you guys, where would my minimum be on this graph of F? A, B, or C? A. You guys agree a minimum's at A, my absolute minimum, right? I'm just going to say a min there. What do we have at B? A max there. What do we have at C? A min there. And what's our rationale with those again? We have a min here because of my F graph because F prime changes from? Great. We have a max on my F graph because F prime changes from? Beautiful. You guys, question. On Wednesday and Thursday, I taught you that the graph here is concave what? Up. Do you guys agree? When something's concave up, we always have a minimum, right? Then, what's my graph doing here? Then it's concave down. If something's concave down, I'm going to have the highest point, a maximum. And then I go back to concave up, boop, and I've got another minimum. That makes sense, right? So, what did we learn the other day? That if the second derivative is always concavity, right? Second derivative is always concavity. If that second derivative is greater than 0 or positive, is that up or down? Okay, so then I'm going to draw a little picture. That means my function has to look like that, right? If my second derivative is positive, we're concave up. Do you agree if my slope there would be 0 right here at my minimum? So if that second derivative is positive, we're always going to have a minimum there. It's just another tool for your toolbox. We could always do minimums using our F prime, but maybe they'll only give you some F double prime info and you're like, cool, if F double prime is positive, I know I'll have a min. What if F double prime is negative? Yeah, if F double prime is negative, we know it's going to be concave down. My function would be concave down. Therefore, I'd have a maximum there. So it says, hey, here's G. Identify those critical points. Again, critical points are just when your first derivative is 0. So let's go find those critical points. Critical point, let's go find G prime. Derivative of 2x squared. 4x minus derivative of natural log 1 over x. Guys, we got to go figure out where that equals 0 or is undefined. Ooh, is my G prime undefined anywhere? Yeah, we finally have a denominator. When would this denominator be equal to 0 when the x value is 0? So we've got a critical point there. Cool. Let's go find also where this equals 0. What might you do to start solving that guy?
Add 1 over x.
Yeah, so we could subtract 4x, but then they'd both be negative. I'd rather add 1 over x. You cool with that, Dar? So we're saying 4x equals 1 over x. Then, Dar, you said do what? You know it. Let's get rid of that denominator. So we'd have 4x squared equals 1. Psh. Divide by 4. Oh, I feel like Graham would have definitely quacked right there. So I'm like not sad that I didn't hear that. Square root of 1/4.
1
1 over 2.
I think it's 1/2.
Bondi,
Oh, plus or minus.
you are killing.
No, Ben said.
Okay, check this out, you guys. Do you agree my critical points are 0, positive 1/2, and negative 1/2?
Yes.
Look at this, though.
Has to be greater than 0. So
What don't we have to worry about? We only have to worry about just the positive half, because it can't be 0 or negative half.
The plus or minus didn't matter.
It didn't, but I think it's important because it could have mattered. So we got to go classify that critical point. So here's the deal. Could we go find like our max and min in our traditional route? Sure. We could go plug in a sign chart, a 1/2 into my sign chart here. I just want to show you something new. If we knew the sign of my second derivative at my critical point, if G double prime of 1/2 was positive, wouldn't we have them in there?
Yes.
And if G double prime, my second derivative, was negative at that critical point, wouldn't I have a max there? So I just want to expose this to something new. So let's go find G double prime as just a new way to do this. You guys, G double prime, what's the derivative of 4x? 4. Ooh, minus the derivative of 1 over x. Don't forget that's the, we would have to go quotient rule. Or could I rewrite that as minus x to the negative 1?
Yeah. That'd just be x though, wouldn't it?
When minus, you only change the exponent, Dar.
Oh, x to the negative.
Yeah, it would become.
It become, negative times negative is a positive x to the negative second. Is that the same as 4 plus 1 over x squared?
Yeah.
No, because you're saying negative.
It's fine. We all got there. Here we go. So our new tool today is what if I explore that second derivative at that critical point? What if I go plug in 1/2 at that second derivative? The new thing today is, oh, if I know if my second derivative is positive there, I'll have a min. What do you think this value is going to be? I don't care what the value is. What do you think the sign is going to be? It's going to be positive. That's greater than 0. If my second derivative is positive, we know my function has to be concave up. Positive, happy face. So when it says write your conclusion, we can just say G has they asked for a relative max or a min. Yeah, relative min at x equals 1/2 because G double prime of 1/2 was positive. Well said. You can say was positive or is greater than 0. Either way, love it. So you guys, what if I gave you this chart? I do kind of like these ones, which must be true. I don't like it when they say could be true, which has to be true. Okay, look at what they gave us. H, my function H. Hey, here's some info about H, H prime, and H double prime. H has an absolute maximum value when x is -4. You guys, let's look at H. At -4, do you agree 5 is the biggest of those y values?
Yes.
But,
They still find it.
true, but let's even think, let's just, I like your rationale. You're like H prime, double prime doesn't even have any kind of concavity. Let's even just think real fast. Well, do we know what's happening at, say, -3? Could I have a value of like 15 right here? You know what I mean? So I'm just going to say, we don't know what's going on. A table does not give you much info. So we're going to say not necessarily. Nope, he says. Is H concave down between 3 and 7?
Yes.
Concave down means that double prime is negative. What about at 4? Could, when X is 4, could it have been positive? Greer is mad right now. Greer is so angry. So it could be true. They want you, I like what you're thinking, Greer, but does it have to be true? Not necessarily. A maximum at 7. A maximum at 7.
Looks like the answer's D.
My H prime would have gone from positive 0 to positive.
That doesn't work.
So that's not going to work.
None of them must be.
Oh, wait. Whoa. Wait, what did I just... Wait, relative maximum at 7. Hold up. Heel.
Wah, wah.
Silly me. You guys, I was saying H prime before and after was positive 0, positive. But do we know what's happening right before 7? No. Stupid me. This could have been positive 0 to negative, right? We don't know. Look at this part. What's H double prime at 7? If H double prime is negative, we are concave down. What do I have there? A maximum. So I do feel good about that. I do feel good about C.
Looks like the answer's C.
Whew. Okay, you guys, what if they give us a little bit of info? They just gave us a point. The slope of that point is 0.
That's good.
I agree. The slope is 0 because a max would have a slope of 0 and a min would have a slope of 0. And then the second derivative is
Negative.
positive at x is -1.
So it's concave up.
So it's concave up.
You got
So I
a
might
minimum.
even draw myself a
We've
picture.
got a minimum.
Middle.
So we've got a minimum there. Because G prime was 0 there. We feel good about it. Yeah?
Yeah.
Okay. And a smiley. What if at -5, we've got this point, cute. My slope is 0 again.
Nope.
My second derivative is 0.
Nope. Not enough information.
We don't have any concavity. If my slope is positive, it's concave up. Negative is concave down. If it's 0, we have no concavity. We don't know. This is how AP likes to ask this. Okay, check this out. They said f of x is the y. Sure. T is the tangent line to the graph. Okay. And it's tangent when x is 2. Okay, great. Look what it says. The tangent line is always greater than the function. If the tangent line is greater, it's got to be above. So if I've got this function, and I'm going to say when x is 2, would you say this tangent line y values are always greater than or equal to the function's values?
Yes.
We feel okay with that? Okay, what about this one? What if I were to draw
So it's
it
concave.
over here?
It's gotta be concave down.
Well, let's look at that one.
Oh.
Do you agree my tangent line t is always, y values are bigger than my function?
Yes.
Okay. What about this guy here?
Nope.
Tangent line t would be under it, right? And even if I put t over here, t would be under it and less than, right? So I'm digging both of
Is
those.
it E? F double prime 2 is this.
Yeah, Dar? So Greer's kind of jumping. He's like, wait, everything that she just drew me was a concave down thing. So you're digging. My second derivative would have to be less than 0 because that means concave down. I'm digging that. Let's look through some others just to make sure. What was this one going to be talking about?
Concave up.
That means it's concave up. We already proved that that'd be less than. So I don't like D. What about this one? F prime. So again, let me just show you real fast. In these graphs here, this is a graph of F. This is a graph of F. I'm going to put that in purple.
No, because it could be negative.
Ooh, you just used it though.
F prime could be negative.
My slope of F prime could be positive or it could be negative, right? And that's what this is saying. Your slope at that tangent point has to be positive or your slope has to be negative. Like, it could be either.
So it can't be C or B.
What's up with A?
It's just the function. It doesn't.
It's just the value of the function.
talking about?
They're saying that y, when x is 2, my y value has to be bigger than 0. That a graph of that would be here. When x is 2, my y has to be positive. But couldn't I have put this graph like in the 4th quadrant? It doesn't matter that those y values are negative. So I agree, Greer. It's E.